Hi, and welcome to this part 5 of our V-block project video. Today, we're going to be drilling holes. And if we're going to drill holes, well, we have to know where we want to drill them. And some of those holes are just through holes, and some of those holes are tapped holes. So, let's start by describing how we're going to attack our parts, because we have two parts. We're going to be producing 3 V-blocks. We have one that we're producing more with home shop techniques, almost by hand. And I have this larger block that eventually is going to be cut into 2 smaller blocks. It's going to end up the same size as this one. But this one we're producing it a little more accurately with over dimensions and grinding and the lot. And we're going to attack the holes differently in one case and the other. On this small home shop V-block, well, we're going to be laying out our lines. We're going to punch them attentively, and then we're going to spot or center drill those holes. Or maybe not. Maybe I'm just going to punch them and use those punch marks to guide my drill. I'll have to see what the chisel edge on the end of the drill, how large it is. In this case, our drill is going to be about 0.2 inches for tap drilling a 1/4-20 hole. So that's how we're going to be doing this one, and we're going to be doing it all on the drill press after it's laid out. This larger block, well, we're going to be drilling by numbers, but even if we are drilling by numbers, it's going to start with a layout. Now, in this case, the layout is what positions the holes. In this case, the layout is going to serve 2 purposes. The layout is going to be used as a safety, and if I miscount the turns that I'm doing with the hand wheels on the milling machine, well, these laid out lines could save my bacon by showing me that I'm really not in the right place. But they can be used for something else as well. The laid out lines are going to be used to really save me time, because I won't have to count my turns all the time like I just said I would. And I'm going to show how we can use those lines to save us some time when positioning on the mill by numbers, without a digital readout, obviously. So that's how we're going to go about it. And important to note that on this second block, the one we're going to be doing by coordinates, well, we'll be laying out our lines, but we won't be punching them. Okay, that's what we're going to be doing. And in both cases, it starts with a layout. So let's head over to our cheap cast iron layout table and start laying out those holes. We're ready to go, but we're going to be laying out. So I have to apply something to give me a little contrast so I can see those lines accurately. And that, well, is going to be layout blue. So let's get some layout blue on the surface I want to lay out on. And remember, these layout lines only need to cross at a very small area. They're just to show the position of a hole. There's no need to smear the whole surface of the part with layout blue. So just a thin coat, and really only where you need it. Now, some ornery old teacher might have done something as mean as offsetting the grooves on the side of this part. And I did. These grooves aren't on center. The part isn't symmetrical at this point. And that means that there is a top and there is a bottom. And that means that the holes go, if I look at the print, in the top of the part and not in the bottom. So make sure you have the part oriented in its proper direction before you start laying out. Now, if we look at our print, the first hole comes to 0.3 inches, 300 thousandths of an inch from the primary surface. Now, I've left some material on this part. I've left about 5 thousandths in that direction, so I have about 1 inch 505 thou. So I'll add a couple of thousandths of an inch to that dimension. So I won't be shooting for 300 thou for that first hole, but really 302 thou. But on top of that, remember, my trusty Starrett height gauge is probably twice my age. Well, it doesn't go all the way down to the bottom. It stops at 1 inch. And that means that I have to raise my part by 1 inch. And that's why I have it on a 1, 2, 3 block. And that means that what I'm going to be setting my height gauge to is actually 1 inch 302 thou. And it's already set there. Then I'm going to be going on to 1 inch 752 thou for the second row of holes. And finally 2 inches 202 thou for the final row of holes. So let's do that, and then we'll get back before we move on to our second block. You may be wondering what this support post is. Well, in the depths of winter, when I get 4 or 5 feet of snow on the roof here, I get a little nervous. So I add a support beam, and that's why this old thing is hanging around, and it's not usually there. So now you know, in a month or so, it'll be gone, and so will the snow. But that being said, we've laid out the rows of holes that I have to do on this small block. And you'll note, and this is important, that I didn't flip-flop the part. I could have laid out the first line, then flipped it over to do the first line on the other side. I didn't do that. Why? Because that's not the way that the dimensioning is presented to me on the print. All the dimensions for the holes, or the rows of holes, are given from the primary reference surface and not from the other side. And I have to respect that. Now, why is that? Tolerances add up, and you have to respect them. So in this case, each hole, or each row of holes, had a tolerance of plus or minus 5/1000ths of an inch. That means that once this project is complete, the first row of holes will be good if they are positioned anywhere between 0.295 of an inch and 305 of an inch. That's easy enough to understand. But if we move up to the total depth of the part, we see that it should be 1.5 inches, and that it also has a plus or minus 0.005 of an inch tolerance on it. And that means that this part would be good if it measured anywhere between 1 inch 495 thou and 1 inch 505 thou. Now, if one block was at its smallest and the next block was at its largest, and so on and so forth, anywhere in between there, and I was making 50 of these blocks, well, if I flip-flop the part around, the positioning of the holes would be irregular on each part, and many of them would not be within their tolerance. So it's very important to respect the reference surfaces and where the holes are dimensioned from on the print. So that's one thing. But this is done for the rows. Now we can move on to our other part. Now I've just said that it was important not to flip-flop the part around. And lo and behold, this part I'm going to flip-flop around. That's just the way it is. Different circumstances can be treated differently. And this isn't one block, it's 2 blocks. I left 1/4 of an inch in the middle here to cut this in two somewhere down the line. And that means that when I set up on one end, well, first I have to decide how much I'm going to leave here. I'm going to leave 15 thou per side. And that I'm going to leave a little more because this one we're going to be grinding on a surface grinder. So I'm going to leave 15 thou. I decide that because I have 250 in the middle. I can leave pretty well what I want here. I don't have a problem. I'm going to sit there and lay out our first line. Now our first line is going to be at 1 inch 315 thou because I left 15 thou on the end. And then, just to save time, I'm going to flip the block over and lay out the other side immediately. Why can I do that? Well, because it's two blocks. This is the reference surface of the block on this side of the part, and this is the reference surface for the block on that side of the part. And all the holes will be measured from their respective reference surfaces. So my tool's already set up for the 1 inch, or I'm going to set up my tool, I should say, for the 1 inch 315 thou line. Flip it over, do the same on the other side, and then continue on with the 4 other rows that need to be laid out. Let's take a look at that. Okay, that's good for my rows of holes. Now I have to draw my lines in the other axis to give me a crosshair that I can punch to or position to. And well, to do that, it's going to be a little simpler. I'm going to be able to do them in tandem because both my blocks have precisely the same width. They come from the same bar and they weren't machined in this direction. So they have the same width. And I have no material or almost none left for finishing. So that's going to be a minimum. I'm probably going to just skim a couple of thou off to finish the sides and be within my plus or minus 5 thou. We'll see how that works out anyhow. But for now, I have to lay out. So my first line is going to be at 0.2, 1 inch 0.2, with nothing else because I have no material left for finishing. And then the next line is going to be at 1 inch 8, so 2 inches 800 thou. So let's set up for our first line, scribe that, and we'll be able, because they're the same width, we'll be able to do our 2 parts without readjusting the tool. And now with our safety glasses on, we can move on to punching those locations on the small block only, not on the large one. And for that, well, we're going to use a prick punch and a center punch. We're going to prick punch the positions first and center punch them after. For the prick punch operation, we're going to be using a very light hammer, and for the center punching, well, we're going to be using a heavier hammer. And it's important to only do this on the small block, because the small block we're going to be finishing on the drill press, so we're going to go from punching to drilling directly. The larger of the 2 blocks, well, it is going to be drilled on the mill, or at least have its holes positioned on the mill by coordinates. Now, if I punch the positions or locations on this large block, my punch marks are going to be 1, 2, 3 thousandths of an inch out, maybe even 4. So why go through all the trouble of going to the mill and positioning exactly above the position, numerical position of a hole, if I have a punch mark there that's going to draw the drill off of that position anyways? No, we do not punch if we're going to be positioning by coordinates. So we're only going to be punching the small block here. There, now my positions are punched and I'm itching to cut something, so let's head over to the drill press and drill out those holes. Now these are going to be tapped 1/4 20 UNC. And for that, well, I'm going to need a tab drill size drill. And for a 1/4 20, well, we'll look somewhere around the number 7, probably a number 6, because this is 4140. It'll be a little easier to tap. Or a 13/64. Anything that comes in around 200, 201, 202, something like that will do just great. So let's head over to the drill press and start drilling. There, I hope we'll get a better camera angle on this one than we did with those punching operations. I think my hands were in the way there. I have mounted here a number 4 center drill, and I'm going to use it to just spot my positions. I'm not going to go way in and produce a big V, no, just really the first tip. And you can see here that I've set my depth so that it's just really below the surface there. Once the 6 holes are spotted, I'm going to have a little fun. Now it's not on the print, but we want this tool to last, so we're going to produce protected threads. And a protected thread is a thread that is a little indented into the part. So the start of the hole is really a clearance for the tap, and then we have a nice chamfer, and then we have our threaded hole as such. If the thread doesn't come right to the top, well, it's harder to damage that thread. And also, seeing as we're going to give a nice chamfer on the sides of the thread, well, the lead-in thread won't be paper thin at the start. It really has full of advantages here. And that chamfer, well, you know, it's going to come with the drill that we're going to use. So we're going to spot with this number 4 center drill. Then we're going to get a drill that's slightly larger than the OD of the thread. So 1/4 inch, a little over. And we're going to come in just about 15 thousandths of an inch deep with that larger drill. And its end is going to be 59 or 118 degrees. And that gives us almost 30 degrees on each side, which is the angle for the thread, and that means that I'll have a nice lead-in chamfer. So I'll drill those with my depth stop, all to the same depth, about 15 thou deep, not really important. And then I'll get my tab drill, a number 7 or number 6, or maybe a 13/64, they'll all work, and I'll drill those holes through before the tapping operation. So let's get in a little closer and take a look at that. Okay, my holes are done, and now I can move on to tapping. I have my 1/4-20 tap mounted, and it's a taper tap for starting a hole. And that's all I need here because the holes aren't very deep. I can make a full thread just with this taper tap. So I have it mounted in the drill chuck, and I've taken off the belt because the last thing I want to do here is turn this machine on when the tap is engaged into the part. You can see no belt, no possibility of turning this thing on. Okay, that being said, I'm going to feed down into my hole with a light pressure. I'm going to turn 2 or 3 turns, 2.5 turns, something like that. I don't want to complete the hole here because I don't have much sensation of what's going on, and I don't want to break my tap. So I just want to start it in there good and straight, and then I'm going to use the axis of the machine to get myself good and straight. So once I'm in there, I'm not going to remove the pressure, because if I let go, this has a return spring. It's going to want to pull the part up, and it could cock the part in relation to the tap and snap the tap. Now I'm going to feed down, engage about 3 turns, and then I've planned ahead of time. I keep my key close in hand and a light pressure on the tap. I come and loosen so that I can pull up the chuck, leaving the tap engaged into the part. And then I can go and complete the tapping operation at the workbench. So let's take a look at that. And there, my first hole is complete. So I could do my 5 other holes in the same manner, but it is a little long and drawn out. I mean, it's accurate, but it does take a lot of time. So I'm going to do another technique for the 5 last holes. It's a little quicker. I've made myself a little tapping block, and all it is a small piece of flat stock. It doesn't have to be accurate as long as it's square, and in it I've drilled a hole just slightly larger than the diameter of the tap that I want to use. So all I'll have to do then is apply a little cutting oil on my tap, position my tab block on the part, insert the tap into the hole, and this block firmly held against the surface of the part. And at that time, well, I'll know that my tool is perpendicular to the hole that I want to tap, and that'll be a quick way of doing it. So I'll show you one, I'll do one with you, and then we're going to skip ahead to when this is done to a picture of all the holes complete. And there you go, 6 completed holes. Note the protected thread, that light indentation, and the lead-in angle on the threads. It makes for a very clean thread that's going to last for years. Now let's head over to our milling machine to position the holes on the larger block. Okay, so I have my part set up in my vise. My vise was already squared up. I have my edge finder mounted in my drill chuck. I'm good to go. But there's a difference here with what I did the last time when we were milling. Because I want to be able to flip the part, I'm going to edge find 2 sides of the part, one end and one side, and set myself to 0 on those surfaces. And I'm going to do the 6 holes on one of the 2 ends from those references. But I don't want to have to set up all again and edge find again. Now I'm going to be where I want to be on the y-axis because my fixed jaw is always going to be in the same place. But on the x-axis it could move when I turn my block around. So what I've done different here, I've just mounted, and you can put a stop here or whatever you want, but I like to keep it simple. I mounted the part in the vise with the part flush with the side of the fixed jaw, not the movable jaw, the fixed jaw. And that way when I flip the block around, I'll be able to come back to the same position. So that is one difference. Now, what are we going to do? Well, with our edge finder, we're going to come and edge find the end on this side of the part. Why not the other side? It's a question of the dials on the machine. Now, the dials on my x-axis turn in a clockwise fashion when I'm going with the part is moving in, when the part is moving in this direction. They go from 10, 20, 30, 40, 50, and so on. And that's the direction I'm going to be advancing in. I'm going to never try and back up once I start positioning my holes on the x-axis. So I'm going to set my 0 on the end, and then I'm going to go to 315 thou. Then I'm going to go to 765 thou, and so on. Always in the same direction. And it's going to be easy to count because my dial is in the proper direction. If I started on the back end here, well, I'd have to read my dial backwards. 0, 90, 80, 70, 60, 50, 40, and so on. And that can get a little confusing. So it's just a little practical thing to keep things simple. In the other direction, I'm not that worried because we're going to be going from one point to another all the time, the two same points. And they fall on nice round numbers. So I'll be going from 0 to 1.6 inches all the time. So we'll see that's going to be quite simple. So I'm going to edge find the end, set myself to 0, move 100 thousandths of an inch because that's half of the width or the diameter of the edge of my edge finder, and that'll position the axis of rotation directly over that surface. That is my working 0. So I'll set my graduated collar to 0 there. And it's going to stay that way. I'm not going to readjust that collar for the rest of this job. Then I'm going to come and edge find the back of the part, set myself to 0. I'm going to move 100 thou, set myself to 0 on this axis here, the y-axis. I'm going to move half the diameter of the edge finder to position the center axis in this direction directly above the back edge of the part. And I'm going to set my axis to 0 there, but that is not my working 0. In this case, I'm going to move to my first hole then. So I'm going to move to 0.2 inches, and there I'll set my new 0. So instead of going from 0.2 to 1.8, I'll be going from 0 to 1.6. It'll be a lot easier to remember. So that's what we're going to do. So let's get the camera in a little closer, and I'll do the edge finding and the zeroing all in one foul swoop. I'm going to start by edge finding the end of the part in the x-axis. I can then reset my graduated collar to 0 and move in the same direction as I edge found the part by half the diameter of the edge finder. That is my working 0 in X. Now I can move 315 thousandths of an inch to position the axis of rotation above my first coordinate. And now we start over in the y-axis. We edge find the back of the part, then we set our graduated collar to 0 and move half the diameter of the edge finder. And since in this axis we're going to be moving back and forth, we're going to add the 200 thousandths of an inch to position ourselves above the first hole and reset our 0 to there. Well, we'll already be on a 0. Now I'm going to swap my edge finder for my center drill and just come and barely touch the surface to see if my position coincides with the two layout lines that I've produced, because right now I should be directly above my first hole at 315 thousandths of an inch in X and 200 thousandths of an inch in Y. So there, my first hole is spotted. Now I want to position my second hole. I'm going to have to move my y-axis by 1.6 inches. Now, the first hole was at 0.2, the second hole I want at 1.8. But seeing as I'm counting that first hole as my 0 in y-axis, well, my second hole will be at 1.6. So that means 16 turns, because each turn is 100 thou. And that means that I'll end up on my 0 again 16 turns from where I sit. And that means that I don't have to count my turns. All I have to do here is lower my tool so that I'm close but not touching my surface and crank away. I'm going to turn until my tool gets close to the other laid out line and then just move to the next 0, and I will have moved 160 thou quite accurately. You see, your layout lines can save you a lot of headaches because they give you something to gauge on. Okay, let's get the camera in close and take a look at that. I can now motor over to the other side of the part, come up to the line close but not go past it, and then move to the next 0, and that'll put me at 1.6 inches. I'm now just going to barely touch the surface to check that I'm in the right position, and then I can spot my hole. Okay, so I've completed the first row of holes, not holes, but positions, the ones that were at 315 thou. And I want to move on to the next row that's supposed to be at 750 plus 15, so 765 thou. But before I move anything here, because I'm going to want to come back here later on, because I'm going to flip this block around, I make myself a little chalk line right here. And that is going to help me greatly to come back to this first row eventually when I have to start over the sequence. Because all I'll have to do is come back just past that line, then return to the point where they line up when I'm on the 15 or 315 mark of my dial. I'll know that I'm right at the right place. But I'm running through this quickly here, and that is because we have a couple of videos that already explain all of this in great detail. And the first, well, is called, I think it's positioning holes, accurate positioning holes on a milling machine without a digital readout. And the other one, well, is producing accurate bolt hole circles without a digital readout. So if you Google either one of those, especially if you put my name in the search, Marc L'Ecuyer, I'm sure you'll find them quite easily. Okay, so what we want to do here is go from 315 to 765. And it's easy, you just got to say where am I and where am I going. I'm at 315, so the next 0 I'm going to meet here, if I always go in the same direction, the next 0 right there is 400. One more turn, 500, one more, 600, 700, 50, 60, 5, bang, I'm where I want to be. So now I'm going to just come down, touch off to make sure I'm in my right position with my laid out line, and then spot that hole. So now it's going to be a little different because I have to go back to the other side, and going back is the important word here. I'm going to have to change directions. I came over to the hole on this side, now I have to go back to the hole on the other side. My x-axis is always moving forward, but one of the two sooner or later has to back up, and when it backs up, well, I get the play in the lead screw or the loose of the lead screw problem arises. So how am I going to deal with that? Well, quite simply, all I have to do here is head over to the other side, go slightly past the laid out line that marks the 0 point for the hole, and then come back in the direction that doesn't have any backlash on it to the next zero, and I'll be right above my hole without any backlash. So that is what I'm going to do. Spot, and I'll just check and spot that hole. Then I'm going to, without breaking away, I'm going to move the x-axis to 700, and no, I'm at 750. I'm going to move it to 1.215, 1 inch 215 thou. For the third row, I'm going to spot that fifth hole, and then I'm going to just move forward as I did right at the start to get back to my sixth hole. Now, you might be wondering, why am I choosing to back up on the y-axis and not back up on the x? Well, the y-axis in this case is the easiest one to back up on, because I'm going from 0 to 1.6, 0 to 1.6. Nice round numbers, easy to remember, easy to get to. Whereas the y, or the x dimension here, is always moving forward in this case. I've chosen that one to do that because I'm going to 315 thou. Then I'm going to 765 thou. Then I'm going to 1 inch 215 thou. And not easy numbers to remember, and a possibility of error there if I get confused. So that's why I've chosen this sequence. Now I'm going to be doing this without breaking away so that you can see that it really doesn't take that long to do this. Actually, spotting these 12 holes would only really take me about 5 minutes if I weren't distracted with the camera. So I'll just put it on. No fast forward this time. We'll just work through it. So I just cross over to the other side, but this time I'm going to go just past the other line and return or come back to it in the direction that I'll take up my backlash in. There's my 0. I'm ready to spot that hole. So now I have to move on to my 1 inch 215. So next 0 is 800, 9, 10, 1.1, 1.2, and 15 divisions. 1.215. And now I want to move to my next line, or come close to it without going past it. Once I'm close to it, the next 0 to come up will be my 1 inch 600 thou, and that'll be my 6th hole. Now I want to flip the block around, so I'm going to move it out of the way in the x-axis just to give me some room to work here, because I'm going to want to seat it with the dead blow mallet. Now I've flipped my part around, and it's very important here, if I don't want to lose my references, that I get it good and flush with the end of the fixed jaw. Now I don't have to count my turns here, because remember, I put that little chalk mark on the table. I'm going to come just past the chalk mark, Then I'm going to come back in the direction that takes up the backlash. For 0 I meet is 300, 315 is where I want to be. So, to get to my next hole, I'm going to be moving in the wrong direction as far as backlash is concerned. So this time I'm going to go past the line on the other side and come back to it in the direction that takes up the backlash. And so I come back to 0 and I'll be where I need to be. Okay, so those two first holes on this end of the block are spotted. And I'm not going to show you the 4 others because I'm going to do them the same way as they were done on the other side of the block. I'm not going to show you how to drill and tap them either because I'm going to do it exactly the same way as I've done the other block. Now, these holes are accurately positioned and we'll maintain that accuracy as we move over to the drill press. So it's not a problem and it's a very efficient way of working on these smaller parts. And I'm going to tap them with the tab block, and that is another efficient way of working on this type of small part. So, what do we have left to do? Well, we still have a through hole to produce, we have a V to rough out, we have a groove to produce in the bottom of the V, and we have to identify our blocks before heat treatment. And that's what we'll be doing in our next video, hopefully next week. So, until then, have fun, be safe, and happy machining.
There you go.